Hello guys, welcome on Tesla Adventures. In this video, let us discuss a accelerating particle accelerating device which is called as cyclotron. Each of you have heard about the Rutherford alpha scattering experiment, and in that experiment Rutherford bombarded the alpha particles, fast moving alpha particles on the gold foil, and to accelerate those alpha particles to such high speeds, he has used the cyclotron device to accelerate those particles. So cyclotron is a particle accelerator, and this is a device which can accelerate the charged particles which are of heavy weight. In fact, we could not accelerate the charged particles through cyclotron, which are of light weight. So it is a device which is used to accelerate those particles which are of heavy weight. Now, why I am specifically mentioning the heavy weight will be explained in the later part of this video at the end. So first of all, let us start the cyclotron and let us study its arrangement, construction and working. You can see that you can imagine that there is a huge north pole of the magnet, or you can see that there is a huge cylindrical magnet whose north pole is facing in the downward direction, and there is a huge similar cylindrical magnet whose south pole is acting in the upward direction, facing in the upward direction. Between these two magnets we have placed a box which is of a shape of a disc having some width, and we have used two metal boxes which are in shape of D. You can see that this is D, and this is evacuated chamber, which means that there is vacuum in the box, and inside that box there are two metal Ds, and these two metal Ds are connected with high frequency oscillators, and this is just a alternating current source. Now let me show you the true arrangement of the cyclotron. So this is the north pole, or this is the south pole. Magnetic field is in the downward direction, and this is evacuated chamber, and there are two D shaped boxes. You can see that this D shaped box is hollow from inside, and particle can enter these two Ds, and then it can rotate and come again to the another D. These two Ds are connected with this oscillator whose frequency can be controlled by us, and let us now discuss the working of these system. So let us see that the particle which is to be accelerated is kept initially between the gap of these two Ds. Let us place the particles in this gap here, like that, and let us imagine now, or what we can do, we can use another page to better understand the situation. Now let us draw the arrangement of Ds. These are two Ds. We are viewing the top view of these two Ds, and these are connected with a high frequency oscillator. So let us do that. So this is a HFO, high frequency oscillator, which is just a AC source or a AC battery. So you know that high frequency oscillator generates AC current whose polarity changes after a fixed interval of time. So let us suppose that its total time period is T, and obviously the polarity will change after T by 2 time. This is T by 2. So you can see that its polarity will change after T by 2, like that. So what we have to do, the particle which we wish to accelerate is kept in the gap between these two Ds, and that particle is being let us suppose that initial polarity was in such a way that this is T, and obviously the polarity will change after T by 2 time. This is T by 2. So you can see that its polarity will change after T by 2, like that. So what we have to do, the particle which we wish to accelerate is kept in the gap between these two Ds, and that particle is being let us suppose that initial polarity was in such a way that this is the alpha particle which is positively charged, and the initial polarity of these two Ds is this is minus and this is plus. So we also know that there is a magnetic field present in this complete region which is inside the plane. So as we know that alpha particle will be accelerated towards the negatively charged D like that, and due to that it would be in circular motion like that, or we can place this charge somewhere in the up direction. Here we can place the charge, and it would be accelerated towards the negatively charged D. Now as soon as this particle will enter this D, the electric field inside this metal D will be 0. We know that the net electric field inside the conductor is 0. So electric field inside this metal D will be 0, and this charge will move under the influence of this magnetic field, and its motion will be circular. So it would perform a semicircular movement in this D, and after the time it would complete this semicircle and it would reappear between the gaps of the Ds. The polarity of this oscillator changes. Now to achieve this purpose, that after each interval of time when the particle reappears between the gap, the polarity of the oscillator should change. So for this purpose we know that the half time period of the particle, this is half time period of the particle, should be equal to the half time period of the oscillator. So their full time period should be same, and the time period of oscillation of the, or time period of circular motion of the particle in magnetic field is 2 pi m by qb, and that should be equal to t. So the frequency or the time period of HFO, or frequency of HFO, is 1 by t, which is qb by 2 pi m. So the frequency of this HFO is controllable, and we can control and we can set this frequency for HFO. So we have done that already, because we know that the mass of alpha particle is constant, the charge of alpha particle is constant, and magnetic field which we have created is constant. So we can already find out the time period of alpha particle by this formula, and we can find out the frequency of rotation of this alpha particle by this formula, and we can set the HFO on this frequency. So as soon as this alpha particle will reappear between the gap of the Ds, this HFO will change the polarity, and now the polarity of this would be, this D would be minus, and the polarity of this D would be plus. So alpha particle will reappear in this gap with some velocity, which was the initial velocity which it rotated at this point, and now there would be a electric impulse acting on this alpha particle towards this D, and therefore its speed will increase, and it would go in a path of greater radius, because we know that radius of circular path is r is equal to mv by qb. So if due to a electrical impulse, due to this electric field of D's, v increases, therefore it would move in a circle of radius which is greater than the initial radius. And now again, when it would again reappear between the gap, the polarity of the D's will again increase, now will again change. Now this D will again be negative and this would be positive, and again there would be an impulse which would increase the speed, and again it would go in a circle of greater radius. This process will continue till the time this particle goes in a circle which is which has the same radius as that of D, and there is a small openings in the circumference of the D's, through which this particle will come out and will strike the target. Once this particle will come out of this circular region, then it would come out through the magnetic field, and hence after coming out through the magnetic field, its path would be straight line due to the fact that it has emerged out of the magnetic field, and hence there would be no magnetic force acting on the particle. So if we try to understand this concept in this arrangement also, so we can see that this alpha particle will start to rotate like that in bigger circle radius, and in the realistic this cyclotron, there is another arrangement in which you can see that this particle is rotating like that. But if we wish that this particle should emerge out of this part, so what we have done, we have used a deflection plate in which let us suppose that if alpha particle is accelerated, then we know that the charge on the alpha particle is positive. So what we have done, we have sprayed some negative charge on this deflection plate. So this alpha particle, when it would be along this path, then this deflection plate will attract this alpha particle, which would slightly deviate this alpha particle from the original path, and it would go in this region rather than going in that region. So it would go in this region, and as soon as it would come out of the D's, it would be ejected from the magnetic field, and hence it would travel on a straight line path, and the target on which we wish to bombard this alpha particle is placed at this position. So it would emerge out of this position and it would strike the target. So this was the complete working of the cyclotron, and I know that you should have understood the fact that it is working on the resonance condition. Now what is the resonance condition? You can easily see that this high frequency oscillator is working on the frequency which is same as the frequency of rotation of the alpha particle or any charge, and it is providing a impulse to a periodic impulse, because it is providing that impulse after each half interval of rotation, and due to that impulse the radius of the path is increasing continuously and the speed is also increasing continuously. So we can say that this external source, which is high frequency oscillator, is providing some constant impulse or constant periodic energy to the particle. As soon as it emerges between the gap, it provides an impulse due to which its radius and its speed increases, but its frequency remains same. So this is the resonance condition between the rotating particle or moving particle and the HFO. So this cyclotron works efficiently only when this resonance condition is fulfilled at all the instants of time. So for resonance condition, the frequency of HFO should be equal to QB by 2 pi m. This is the resonance condition of the cyclotron. Now there are some limitations. Now if we discuss the principle of working of cyclotron, then we can easily say that it works on the fact that when a charged particle is moving in a perpendicular magnetic field, then its path is obviously circular, and its motion is accelerated, because we know that circular motion is accelerated motion. But there are limitations of the cyclotron. So let us discuss the first limitation of the cyclotron. Limitations of cyclotrons. So the first limitation of cyclotron is the fact that it could not accelerate the uncharged particles, because on uncharged particles there would be no electric force as well as no magnetic force. So we cannot accelerate the uncharged particles through cyclotron. So the first limitation is that it could not accelerate the uncharged particles. And second limitation is very crucial. So let us discuss the second limitation. So the second limitation is the fact, let us write down the second limitation first. So the second limitation is the fact that we cannot accelerate a light weight charged particle through cyclotron, and this is due to the special theory of relativity given by the Albert Einstein. Now let us discuss how we cannot accelerate the lightweight charged particles. We know that according to Einstein, the mass of any moving object is not constant, and if that object is moving somewhere near the speed of light, then its mass starts to change with the speed of that particle. And you can see that by if it increases the speed, then mass increases. So this concept is not applicable on us in our day-to-day life, because we could not move at these order speeds which are nearer to the speed of light. But when we will accelerate this light particles in the cyclotron, then it would achieve, see, we know that if there are two particles which are thrown with same kinetic energy initially, and one particle has some lesser mass and the other particle has greater mass, so we know that the particle with the less mass will attain higher energy, higher velocity, because we know that the kinetic energy of the particle is equal to p square by 2m. So what we can say, in fact, we can say that if the electric impulse on the particle is same on both the particles, then the particle which is moving with the greater kinetic energy will be the particle which is having the less mass. So we can say that the lighter particles will attain a greater speed in the cyclotron, and due to that greater speed, their speed will start to get near to the speed of light, and hence their mass will start to vary. And we know that the time period of the oscillation or frequency of the oscillation, f, or we can talk about the time period, it is 2 pi m by qb, time period of rotation of that particle. So if m changes, this t will change, and but we know that time period of HFO, which we have already fixed, because HFO is a machine and it would be continuously working on that time period which we have fixed on that machine. So the HFO time period will remain same, which is 2 pi m naught by qb, but the mass of the particle is varying according to this relation, and therefore its rotation time period is varying. So due to this effect, the resonance condition will be finished between the particle and the cyclotron, and in each time when the particle will reappear between the gap of the D's, the polarity of the D will not be reversed, due to which, let us imagine that if the alpha particle accelerated towards this D, then it would be negatively charged, and as soon as this alpha particle will return between the gap, then the polarity does not changes. Then when the alpha particle will return in the gap, then it would be deaccelerated, because this plus D and this minus D will pull this alpha particle back. So it would not be accelerated, and cyclotron, which is a device to accelerate the particle, will not work. So therefore we cannot accelerate the particles whose mass is lower. In fact, we can accelerate the particles with the greater masses in the cyclotron, like alpha particles. Now let us also discuss the radius ratio of the charge particle in the cyclotron after each half circle. So we know that if we again draw the cyclotron like that, these are 2Ds, and if we see that the first radius of the alpha particle was R1, so if we say that R, or we can say that R will be equal to under root of, in fact we know that R is momentum upon QB, but we also know that momentum is under root 2m into kinetic energy by QB, and we know that the work done by the D is the work done by electric field, is the kinetic energy of the alpha particle or any charge which we are accelerating, and that is Q into V, where V is the potential difference between these two D's. Okay, so in the first case, when initially the particle was at rest, the work done by the electric field is QV. So the radius of the first semicircle will be under root of 2m QV by QB. Now again, when this particle will again appear in the gap, then we know that its kinetic energy is already this one, and the work done. Now you should always remember the fact that if V is the potential difference between these two D's, then you should always remember that this particle has started from the gap. So the potential difference, if we are writing down that this is point A and this is point B and this is C, so VA or VB minus VA, or let us suppose that it is initially negative and this is positive, so VA minus VB is V, so VC minus VB will be V by 2. So the first radius will be QV by 2, and there would be a 2 here. So the first kinetic energy of the particle will be QV by 2. Now when the particle will move from this D to this D directly, then it is moving from B to A directly. You can see that it has reached inside the D and it is moving from this D to this D. And initially for the first time it has initiated its motion from C to B. So when it would move from B to A, then it has been accelerated through a potential difference of V and not V by 2. So the new kinetic energy K nu of the particle will be QV by 2 plus QV, which is the additional kinetic energy. So this is 3 by 2 QV. So the new radius, this is R1, this is R2. R2 would be under root of 2mQV by 2 into 3 divided by QB. And again, when this particle will reappear, then its kinetic energy nu, or 3 we can say, will be 3 by 2 QV plus another QV. So it would be 5 by 2 QV. So the new radius R3 will be under root of 2m QV into 5 by 2 divided by QV. So you can see that if we find out the ratio of R1 is to R2 is to R3 and so on, then it would be equal to 1 is to root 3 is to root 5 and so on. So it would be a ratio of root of odd numbers. So this was the important concepts, and it was being asked in JEE Advance once upon a time, and this is important part of cyclotron. So in the next video we'll be bringing the Hall effect in the magnetism. Thank you.